Hi, and welcome to Section 2, Understanding Azure Text Analytics. In this section, we will explore the 4 key aspects of the Text Analytics API, before looking at how we construct requests and analyze the results. But firstly, we're going to look at the 4 key aspects of the Azure Text Analytics API, what they are and how they work. Then, by using our function app from Section 1, we will take a look at how we create requests to the Sentiment Analysis API. Next, we look at Keyphrase Extraction and how we can detect language with the Language Detection API, as we add more code to our application. Finally, we look at linked entities and named entity recognition, and how we create and issue requests to the Entity Identification API. The 4 key aspects of Azure Text Analytics. In this, the first video of Section 2, I hope you'll gain a good basic understanding of the 4 key aspects that make up Azure Text Analytics. There are 4 key aspects that can be leveraged with the Text Analytics API: sentiment analysis, key phrase analysis, language detection, and entity identification. Each of these aspects provides a unique benefit, so let's take a look at each aspect in turn and understand what benefit it offers and how we can utilize it. We'll also get to see some of the JSON responses we received back from the API later on in this course. So the first aspect is sentiment analysis. Put simply, this is detecting how positive or negative a piece of text is. This is done by returning a value between 0 and 1. Let's look at some examples and also some JSON response from the service. So let's add a string that said, "I had a great day at the beach today." Then the system would return a value very close to 1, perhaps 0.93. This would show a high confidence that the string showed a positive sentiment. Conversely, if I had a string that said, "I really hate bananas," then the system would return a value closer to 0, indicating a negative sentiment. Obviously, not every string will be so clearly positive or negative in sentiment, and there is a fair degree of granularity between 0 and 1. But generally speaking, if the value is over 0.7 or below 0.3, you can be sure of the result. So, thinking back to our scenario, if our company is monitoring our social media feeds, we could use this to detect content with a positive or negative sentiment and highlight that for further analysis or processing. Now, let's look at key phrase extraction. The goal of key phrase extraction is to identify the key talking point of a given piece of text. Consider this text: "I really love this course." The sentiment is positive for sure, but sentiment analysis only gives us part of the story. What exactly are they positive about? The answer in this case is obvious. It's the course. So by using key phrase extraction, we can actually identify what somebody is positive or negative about. In most cases, the key phrase extraction and sentiment analysis go hand in hand. And by giving context to the data in this way, it makes the analysis much more valuable. The third aspect is language detection, which is designed to detect what language a piece of text is in. As with sentiment analysis, it returns a value between 0 and 1 to indicate the confidence. With this string, you can see the language detected is English, and it's 100% confident of that. This is commonly used in chatbot scenarios where we need to be able to communicate with a diverse audience using many different languages. Currently, language detection can support 120 different languages. Finally, we have entity identification, which is currently in preview. There are 2 elements to entity identification: entity linking and named entity recognition. Entity linking can pick out all of the named entities in the text, for example, organizations, people, locations, and much more. It helps to remove ambiguity by linking text to additional information on the web, and it uses Wikipedia as its back-end model for this. So, for example, the phrase "many temples of Mars" identifies Mars as an entity and returns a link to the Mars Wikipedia page. It's clever enough to know that we're talking about the Roman god and not the planet. Named entity recognition helps identify different entities in the text and categorize them. This can help identify quantities, dates, URLs, email addresses, and much more. For example, the text "The Battle of Hastings took place in 1066" would identify, amongst other things, the date 1066 as a date time. So what did we learn? We learnt that sentiment analysis and keyphrase extraction can work hand in hand to provide a much greater understanding of our text, that we can identify the language of our text, and that we can identify and categorize our text, as well as finding links to remove ambiguity